Today we're going to be working on section 3.4, and the goal is to be solving exponential and logarithmic equations. So the first two that we're going to work on is what we call common base. So I would just label that because we're going to have all different types. So these are the first two, and this is when we can get a common base on both sides. So I have 2 to the 3x minus 8, and I know I can rewrite 16 as 2 to the 4th power. And now that I have the same bases, I'm able to set my exponents equal, and I can solve for x. So I would add that 8 over, and I'm at 12, divide both sides by 3, and x equals 4. So again, very similar to the idea of evaluating logs, we were always able to solve, so same idea. So here's another one, again, where I can get the same base on both sides, so our common base would be 3. So 27 is 3 to the 3rd. And then notice I still have this x plus 3 up here. 9 is 3 squared, and I still have this x minus 1. And now that I have the same bases, I set my exponents equal, and I am going to have to distribute here on both sides. So I'll get 3x plus 9 equals 2x minus 2. So I'm going to subtract 9 from both sides. So I'll have 3x equals 2x minus 11. I'll subtract this 2x over, and I get that x equals negative 11. So now we're going to get into the ones where we can't get the same base on both sides. So here, no matter how I rewrite 4 or how I could rewrite 15, I'll never be able to have the same base on both sides. So we need to approach this problem differently. As far as like a educated guess, we know 4 to the 1st power is 4, and I know 4 to the 2nd power is 16. So if I had to take an educated guess, I would say that my answer is closer to the 2 range because I need to raise 4 to a power and get 15. So for a problem like this, I'm going to put this problem into log form. So I'm in exponential form, I'm going to put it in log form. So when I do that, I know I have log base 4 of 15 equals x. And now to type this in the calculator, we have to change our base because the base in the calculator is base 10. So the way we change the base is we would type log 15 divided by log 4. So if you just want to make a note maybe off to the side that if I have log base a of b, the way we type this in the calculator would be log b divided by log a. So when I type this in the calculator, we get 1.95, so x equals 1.95, and again we'll practice the actual typing of it tomorrow. So here's our next one. Again, we put it into log form because I can never get the same base on both sides. So I have log base 10 of 120,000 equals x. And this one you don't really need to change the base for because remember calculators are in base 10, so I can just type log 120,000. And when I do that, we get approximately 5.08. So again, those are two basic ones. We're going to do 2 more that are on a little bit more difficult side. So here there's more steps to it, but I still wouldn't say that this one is extremely difficult. So I need to isolate my base of e as much as possible. So I'm going to add that 3 over. So now I'm at 40e to the 0.06x equals 240. And then we got to divide both sides by this 40 out front. So I have e to the 0.6x equals 60, or 6, sorry. And now we're going to put it in logarithmic form. Now, because the base is e and not a number, we want to use natural log. So I'm going to say that this is the natural log base e of 6 equals 0.6x. And again, on our calculators, the natural log is in base e, so I don't need to change the base here. I can just simply type natural log of 6, and then I'm going to divide that answer by 0.06. So there's two ways you could write this answer. I would say you could either say leave it as ln of 6 divided by 0.6, or if you want to write the approximate answer, you could say 2.99. So I'd accept either one. So the last one I would say is one of the more challenging ones, and I'll show you in a moment. So again here, I can never get the same base on both sides. I have a 5 and a 4, and they're never going to be the same. It's also a little different because I can't really put it into logarithmic form because I have exponents on both sides. So when I have a problem like this, I'm going to introduce this idea of log to both sides. So because I'm introducing the log to both sides, you're kind of keeping things equal. If you did it to one side, you have to do it to the other side. And now in the next step, we're going to apply our power rule. And the power rule says that these exponents are going to come out front. So I have this quantity of x minus 2 times log 5 equals the quantity of 2x plus 3 times the quantity of log 4. And in order to solve for x, I got to distribute these logs in so that I can move my terms around. So we're going to distribute it just kind of, you're distributing from the back end, so it'll be x log 5. So it's the same idea, it's just the terms on the end instead of the beginning. Minus 2 log 5. On the right hand side, I have 2x log 4 plus 3 log 4. And now the goal is I need to get any term with an x on the one side, and I need to get a term without an x on the other side. So I'm going to subtract this 2x log 4 over to both sides. And I'm going to be adding this 2 log 5 over to both sides. So I'm going to have to flip the screen so I can kind of finish the problem over there. So from here we have two more steps. So I can factor an x out on that left-hand side, so they both have an x in common. So if I factor the x out, I'm at log 5 minus 2 log 4. And this is still equal to this quantity over here. And if I want to get, like I said, if I want to get x by itself, I'm going to divide both sides by this quantity right here. So x would equal 3 log 4 plus 2 log 5 all over log 5 minus 2 log 4. So again, this would be an example of a more challenging problem because there's way more steps to the process and it's a little bit more confusing and not as concrete as the other ones. So we will definitely do some practice on this tomorrow.